The voltage divider circuit technique is an extremely useful and very simple technique that applies when resistors are connected in series. So let me show you how it works. So in here I have a circuit that is a single loop that is composed of a voltage source and a couple of resistors. And specifically these resistors are connected in series, and that's what I'm interested in. So I know the voltage, the total voltage across these two resistors, and what I'm really interested in, how does this V1 relate to that total voltage Vs, and how does V2 relate to that voltage Vs in here. So what we can do is we can write KVL equation in here. So KVL tells me negative Vs plus V1 plus V2 equals 0. But we know that the current going through all these elements is the same current in here because they're connected in series. So I can apply Ohm's law using I on this one, and I can apply Ohm's law using I on this particular circuit in here. So I can rearrange these terms, so that tells me that V of S, or negative Vs, plus I R1 plus I R2 is simply 0. I can rearrange these terms just to figure out what I is. I will see that I is simply V of S 1 divided by R1 plus R2. That's basically a little bit of algebra. Using a little bit of algebra, we'll be able to get that. Now, what I'm interested in is, again, is V1 and how to relate to Vs. So let's write an equation for V1. Well, based on Ohm's law, V1 is simply I times R1, but we know that I is this particular term. So let me just write it in here. So I is just simply V of S times 1 over R1 plus R2, but we're multiplying by R1, so R1 plus R2. And similarly, we can figure out what the voltage V2 is, and we can say that it's Vs times R2 divided by R1 plus R2. You can write the same exact method or the same approach to get them. So this is what voltage divider rule is. So what voltage divider rule tells me that if I have two resistors connected in series and I know the voltage across both of these resistors, which happens to be Vs in this particular case, well, if you want to get V1, it's as simple as saying, well, V1 is Vs, the source, times some sort of a proportional fraction. And this fraction is simply the value of R1 divided by R1 plus R2. That's what we have. Now, if you're interested in V2, what you do is you multiply Vs times R2 divided by R1 plus R2. That's what this equation tells me in here. So what it really tells me is R1 is definitely smaller than R1 plus R2. At least, well, we can say that this one here is less than or equal to 1. Of course, if it's equal to 1, that means R2 is 0, which defeats the purpose anyway. We're not interested in that. And similarly, we can say that this one here is also less than or greater to 1, or less than or equal to 1. So in both cases, we'll see that V1 is a proportional Vs, or a fraction of Vs, and V2 is a fraction of Vs. And in both cases, V1 is directly proportional to R1, and V2 is directly proportional to R2. The higher the R1, the higher the V1, the higher the R2, the higher the V2. So what we say is that voltage Vs happen to be divided into V1 and V2. And the proportion or the fraction of the division depends on the value of R1 and R2. And that's why this is called voltage division rule. So this particular technique is super simple, or simple useful, because a lot of the times we will end up with a couple of resistors that are connected in series, and we're interested in one of the voltages, not the other. And you do not have to go and write the KVL equation for it. What you have to do is just go ahead and after a little bit of experience, you'll start memorizing this equation. It's really not difficult to memorize. It's just, if you're interested in Vs, or V1, you just say Vs times R1. If you're interested in V2, you say Vs times R2 and divide by the sum. This also applies not only to two resistors in series, you can actually apply it to multiple resistors in series. So in here, I'll show you the general rule for multiple resistors connected in series. So in here, I'm showing you a lot of resistors. So let's assume that you're interested in the R4. Well, you can simply tell me that the V of the R4 is just simply the voltage source, let's call it Vs in here, times some sort of a proportion. That proportion is the value of the R I'm interested in divided by the R equivalent to R1 plus R2 plus blah, 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 all the way to Rn. And I can go through the commotion of like just going through the proof and KVL and KCL, but really what I'm interested in is the general rule. So the general rule, if you're interested in some sort of V of J, let's call this here Vj, for example, in here, okay? simply you say it's the V of source, or V, it's up, or we can say V, basically the voltage across all of them between here and here, that's the voltage across all of them, times R of J divided by R equivalent. Okay, that's the general rule for a voltage divider rule that applies to multiple resistors, not only one resistor. And again, this fraction tells me that Rj and R equivalent, this is less than or equal to 1. So all of these voltages are smaller than the source V. So again, we say that this voltage source got divided between R1, R2, R3, R4, and so forth. So this is why it's called a voltage division. And just to end here, so this does not have to be a voltage source in here. Sometimes what we do have is we have just a circuit in here, and this circuit happened to give me that the voltage between these two terminals in here happened to be V, and what we say is this particular V got divided between these parallel or series connected resistors, and we can use the voltage division rule or voltage divider rule just to figure out the voltage across this or that, depending on the value of R2 and the R equivalent of these series connected resistors.